So in example one, we don't just have a tangent graph, we have some changes in it. And so I see that I'm going to have an amplitude of 2, and then I'm going to have a change in period. So the period is 2 pi divided by pi over 6, which is going to be 2 pi times 6 over pi. Pi's cancel and I get 12. So those are the changes. We also see that I'm not adding anything in front, so my vertical displacement is 0 if I asked for it. And then I'm not subtracting or adding anything to x, so my phase displacement is 0. For a lot of you, you like to make tables, so I'm going to make a table. But when we do that, I'm going to think about sine think about cosine, because tangent is sine over cosine, and we can't let cosine equal 0. So we're going to make a table for the cosine, because that's what I'm going to graph a dotted line for. And then I'll make the tangent graph from that cosine table. So let's start with our normal critical numbers for x. 0, pi over 2, pi, 3 pi over 2, 2 pi. And then the first thing we're going to do is divide by your b value. So we're going to divide by pi over 6, but that is a fraction. So to divide by a fraction, you multiply by the reciprocal. So that means I'm going to multiply by 6 over pi. So I go through and I do all that. So 0 times 6 over pi is 0. Pi over 2 times 6 over pi is 3. 6 over pi times pi is 6. 3 pi over 2 times 6 over pi is 9. 6 over pi times 2 pi is 12. And we should see there's a pattern. It's going up by 3 each time. Then what I would do is subtract 0 from all those. So I'll make a column just so all these tables look the same, but there's nothing happening. So these are the x values that we're going to see on our graph. Then we're going to put the y values. Remember, I want tangent, but I'm using cosine because cosine's on the bottom. So we start with cosine. Cosine starts at 1, 0, negative 1, 0, 1. And there's a 2 in front, so we're going to multiply all those by 2. So 2, 0, negative 2, 0, 2. And then this is a stupid move, but there's nothing in front, so we're going to be adding 0 to all those. 2, 0, negative 2, 0, 2, so nothing has changed when we add the vertical displacement. So those are the y values we're going to plot. So let's go ahead and make this cosine graph first. We start with our x values. 0, 3, 6, 9, 12. Then we put our y values, 0, 2, and negative 2. And at 0, we have a point at 2. And then 3, we have a point at 0. 6 is at negative 2. 9 is at 0. 12 is at 2. And we make a dotted cosine curve, because this is not really the graph we want. We want tangent. So we graphed those points, and now we have this dotted cosine graph. And then we can't let cosine equal 0 in the bottom. So that means anywhere where cosine is 0, which is at 3 and at 9, we draw vertical asymptotes. And then tangent crosses in the middle, so at 6, on the sinusoidal axis, and curls up to the right, down to the left. So it's going to cross at 0 and curve up to the right and down to the left. It's going to cross at 12, up to the right, down to the left. So my tangent graph are these solid lines. And my domain is all real numbers except when x is 3, 9, and so on. And my range is negative infinity to infinity because it's one solid smooth curve from the bottom to the top. So that is your tangent graph. Let's look at this cotangent graph that has changed. I'm seeing a vertical displacement of 3, an amplitude of 2, a period of 2 pi because there's no number in front of the x, and a phase displacement of positive pi over 2. That was supposed to be a 2 pi. Positive pi over 2 because you do the opposite of what you see in the parentheses. Let's make a table. For those of you that like to make tables, we've got x. I've got 0, pi over 2, pi, 3 pi over 2, 2 pi. Then I'm going to divide by 1, which doesn't do anything. I'm dividing by 1 because that's my b value. And then I'm going to add pi over 2, add my phase displacement. So 0 plus pi over 2 is pi over 2. Then I've got pi over 2 plus pi over 2, which is just pi. So pi over 2 plus pi over 2, they have a common denominator. We can add them. That's going to make 2 pi over 2, and the 2's cancel. So I've got pi and pi over 2. If I add those, I'm going to need a common denominator. So pi, we can change to 2 pi over 2. 2 pi over 2 plus 1 pi over 2 is 3 pi over 2. 3 pi over 2. Then I've got 3 pi over 2 plus 1 pi over 2, which is 4 pi over 2. And 4 over 2 reduces to 2 pi. 2 pi plus pi over 2. I need a common denominator of 2, so if I put a 2 on top and on bottom, I'm going to have 4 pi over 2 plus 1 pi over 2, which is 5 pi over 2. So those are the x values. They weren't very nice. Then I've got cotangent. So cotangent is cosine over sine. We can't let sine equal 0 since it's in the denominator. So we're going to graph a sine wave. So we're going to put sine, which starts at 0, then 1, 0, negative 1, then 0. And there is a 2 in front, so we're going to multiply those by 2. So 0, 2, 0, negative 2, 0. And then there's a plus 3, so we're going to add 3 to all those. 3, 5, 3, 1, 3. So those are the y values that we plot. And we're going to make a dotted sine wave out of those. So on my x-axis, I have pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. On my y-axis, I have 1, 3, 5. And I'm going to draw my sinusoidal axis at 3. So now I'm going to graph my sine. At pi over 2, it's at 3. Pi is at 5. 3 pi over 2 is at 3. 2 pi is at 1. 5 pi over 2 is at 3. And we make a dotted sine wave because it's not really our graph. Anywhere where the sine graph crosses the sinusoidal axis is when I would get 0 in the bottom. So I draw asymptotes at pi over 2 because it's crossing the dotted line, and at 3 pi over 2 because it's crossing the sinusoidal axis, and at 5 pi over 2, again, because it's crossing that dotted line. So that's where your asymptotes are. And then cotangent crosses in the middle on the sinusoidal axis and curls down to the right. So that means at pi, it's on the sinusoidal axis, and it curls down to the right, up to the left. In the middle, on the sinusoidal axis, down to the right, up to the left. So that is my cotangent graph. So the domain is all real numbers except when x is pi over 2 because there's an asymptote, 3 pi over 2 because there's an asymptote, 5 pi over 2 because there's an asymptote, and then dot, dot, dot. Your range is negative infinity to infinity because it's one smooth curve going up and down. Last graph, we've got a cosecant graph, and I'm seeing a vertical displacement of 3. I'm seeing an amplitude of 2, a phase displacement of 1, and a period of 2 pi divided by pi over 6, which is going to be 2 pi times the reciprocal, which is 6 over pi. Pi's cancel, and I get 12 for the period. Also, let's notice that it's a cosecant graph. So that is 1 over sine, and I'm going to be graphing a sine wave to find the asymptotes. So let's make a table out of this. We start with our x values, which are 0, pi over 2, pi, 3 pi over 2, 2 pi. Then we take the pi over 6 and we divide by it. So we're going to multiply by the reciprocal, 6 over pi. So 0 times that is 0. Pi over 2 times that is going to be 6 pi over 2 pi, which makes 3. 6 over pi times pi is 6. 3 pi over 2 times 6 over pi is going to be 18 pi over 2 pi, which is 9. And then 6 over pi times 2 pi is 12 pi over pi, or 12. Then that minus 1 tells me to add 1 to all those values. So 1, 4, 7, 10, 13. These are the x values we're going to put in the graph. Then cosecant is sine. So we're going to write down a sine wave, which starts at 0, 1, 0, negative 1, then 0. There is a 2 in front, so we multiply those by 2. 0, 2, 0, negative 2, 0. Then there's a plus 3, so we add 3 to all those. 3, 5, 3, 1, 3. So those are the y values we're going to plot. So we go to our graph. Let's label the x and the y axis. My middle y value is going to be my sinusoidal axis. So draw your dotted line. And now we graph a dotted sine wave. So at 1, we have a point at 3. 4, we have a point at 5. 7, we have one on 3. 10's at 1. 13's at 3. Make a dotted curve. Draw your asymptotes wherever the sine wave crosses the sinusoidal axis. So we have asymptotes at 1, 7, and 13. And then we draw our cosecant curves, which at 4 will start at 5 and curve up. And then at 10, it starts at 1 and curves down. So that is our cosecant graph, which has a domain of all real numbers except at the asymptotes, which are 1, 7, and 13. And then it has a range of, let's start at the bottom, so negative infinity for the arrows, to 1 because of the point,